You need your note packet, a pencil, and you want to be on pages 3 and 4. We're going to talk about, we're still in the sequences and series unit, and today we're talking about the name of the lesson is how many employees. The first problem, in the first month of a new startup's operation, the company has only 4 employees. Each month, the CEO hires more employees to keep up with the growing business. By the second month, there are 7 employees, and by the third month, there are 10 employees. The CEO keeps hiring according to this pattern. So, what are we going to do here? I'm going to get my pen ready. We're going to complete the table. So, if in month 1 there are 4 employees, month 2 there are 7 employees, and we're going to follow this pattern, well, the pattern is going to be there looks like they're going up by 3. So then month 3 will be 10, month 4 will be 13, month 6 will be 19, and if we keep going like that in month 7, 8, 9, 10, all the way to 11, we're going to be at 34 employees. So how does the number of employees grow from month to month? Well, let's write this down. 3 more employees are hired each month. What does that say? We have a common difference, which we've already learned about. This is nothing new. The common difference, that's our D value, is 3. If we look up here, we can see that we're going up by 3, and so forth. So obviously, you're very familiar with videos, and so you should be obviously writing when I'm writing. So a name of this, what are we dealing with? We talked last week about arithmetic and geometric. Well, this is obviously an arithmetic sequence because we're adding. Whether we add or subtract, that's called arithmetic. All right, number 3, plot the number of employees in each month on the graph. So that's what we're going to do next. What do you notice? Well, I'm going to fill in that table again here. We have 10, we had 13, 19, and 34. So in month 1, there were 4. In month 2, there were 7. In month 3, 10. Month 4, 13. If we keep going, month 5 would be 16. Month 6, we already know, is 19. And if we, month 7 would be 22. I'm going to fill these in. 25, 28, and 31. So let's plot those. Month 7, 22, 25, 28, 31, and all the way to month 11, which is 34. Well, what do you notice? Well, if I look at that, I'm going to write what I noticed. What I notice is it goes up in a straight line, linear. Assuming this pattern continues, how many employees will there be after 2 years? That's 24 months. How do you know? Well, think about this. We started, and we should write this down, with 4. And what did we do? And added 3 employees for the 23 following months. Well, what's that going to look like? Let's try to create an equation for that. 4 plus 3 times 23, that's going to be 73 employees. That's what's happening here. We could manually keep adding 3, but a quicker way to get there is we started with 4. All we're going to do is add 3 times 23, that's 73. So I'm starting to write it a little differently because it's going to lead me to a formula that we're going to use called the explicit rule. So think about what we have. Our n is 24. What's in here is 23. So that's really n minus 1. But I'm not going to write n. I'm going to write what n is. It's 20. We know it's 24. 24 minus 1. That's another way to write it. All right, example 5, can you write a rule that will give the number of employees after n months? That's what I was trying to do to show a pattern. Check to make sure your rule works. So on the last one, let's go back a minute. The result is our number of employees. That's our nth term of our sequence. So we're going to write a sub n. We're starting with 4. We added 3 times n minus 1. That's exactly what we did back here. Started with 4, we added 3, and what's this 23 is really n minus 1. Now, I want to do something here algebraically. If we distribute that 3, we get 3n minus 3. Whoops. I can combine like terms. 4 minus 3 is 1, so we get 1 plus 3 times n. We can also write it, obviously, switching it around by the commutative property. And, oh, this kind of looks like something. Y equals mx plus b. So what we're going to find here is our m, in this case, our slope is 3. That kind of is going to go with our common difference. Our y-intercept is 1. And what we're going to find as we continue on here, I'm going to write it in the next group of notes, that's really going to be our initial value is going to always be our y-intercept. So if we did check this, remember I said to check, if we check this, going back to, well, we could just use this formula right here. Let's just check when n is 3. Then the third term is going to be 1 plus 3 times n. 1 plus 9 is 10. Well, if we go back, in the third month, how many employees were there? There were 10. So this is just what we're going to learn in this lesson is, besides using the recursive formula, which is what we were doing here, continuing to add 3 to the prior term, there is a quicker formula called the explicit rule, where if we have the starting term, we can find the 100th term of the sequence or the 2000th term of the sequence quickly versus just keep continuing to add 3, add 3, add 3. Okay, so now comes, remember that's kind of the investigation part. But since I am not in class with you today, we couldn't do that, so I investigated with you in a video. So let's write down our notes now. Here we go. So in arithmetic sequences, we already know this, have a common difference. And that common difference is denoted by the letter D. We just, in our investigation, just came up with an explicit rule, which I'm going to write down. The nth term of a sequence, you start with the first term, You add the common difference times n minus 1. That's what we just did. So I'm going to label some of this. A sub n, I want you to write down, that is considered the nth term of sequence. This is called the first term, a sub 1. We already know the letter D represents common difference. Now, another way to write this, which is what we did when we distributed the letter D, the common difference, is another way is the nth term. If we have the 0th term and we add the common difference times n, that's another way to find the nth term of the sequence. Whether we use the green formula up here or the blue formula, you're going to get the same nth term. The only difference is, with the green formula, you're starting with the first term. With the blue formula, you're starting with the 0th term. And sometimes you're going to be given, you might just be given the 0th term. Sometimes you might just be given the first term. And then, if that's the case, I would use the green formula here if you're given the first term, the blue formula if you're given the 0th term. All right. So this goes back to, I'm going to write one other little thing here that we talked about. Remember, this equates to y equals mx plus b. And I said I would tell you this. The common difference is always your slope, and the 0th term is always your y-intercept. Not the first term, the 0th term. All right. If you have a rewards card at Big B, you earn a free drink after every 12 drinks you buy. Can the total amount of money spent at Big B after ordering n drinks be considered arithmetic? Why or why not? Well, the answer to that has to be no, and I'm going to write why. And you should also write this. Because each purchase does not cost the same amount. Also, the 13th drink adds no charge because it says you earn a free drink after every 12 drinks you buy. Therefore, there is no common difference. It's like going to Starbucks, right? Or anywhere. Kowalski's, Caribou. If I buy 12 drinks, I could buy 12 different drinks. They're not going to all cost the same amount. So that is why that is not arithmetic. Number 2. Determine whether each sequence has a negative common difference. That means the D value is negative. Well, as I look at A, I can see going from 64 to 32, I'm going down by 32. From 32 to 16, I'm going down by 16. From 16 to 8, I'm going down by 8. From 8 to 4, I'm going down by 4. Well, this is not an arithmetic sequence, since there is no common difference. What you're going to see on this one, I'm going to scroll a little bit here. This is a geometric sequence. Ooh, let's write that again. R is 0.5. That's a common ratio. Looking here, if I take 64 times 0.5, I get 32. Times 0.5, I get 16, and so forth. So this A is not an arithmetic sequence, so therefore it can't have a negative common difference. Part B, the daily odometer reading on a car after driving 15 miles every day. That does not have a negative common difference. because 15 miles gets added every day, so your common difference is a positive 15. This is a positive common difference, not a negative. All right, on to number 2C. Determine whether each sequence has a negative common difference. Clearly explain your reasoning. Well, the answer to C is no. The points are not linear, so not arithmetic. And on D, let's see, we're going down by 5, down by 5, down. Oh, be careful, be careful, be careful. They're trying to trick us. There's a 4 in there. So yeah, there's a 5 down. I gotta go back a minute though. Okay. So yeah, that's going down by 5, down by 5, down by 5. So always check over here. It almost tricked me. I almost thought we were going down by 10. We were not. So yes, the term value goes down by 5 every time. I gotta fix. This doesn't look like a 5. So your common difference is a negative 5. 3. A family cell phone plan is sold for $35 a month for the first line and $20 for each additional line. We're going to write a recursive formula for the monthly cost of the plan for end users, and then we're going to write an explicit formula for the monthly cost of the plan for end users. Wonderful. All right, well, what do we know? We know that the first term of the sequence is 35 because it says a family cell phone plan is sold for $35 a month for the first line. So therefore, we also know that our common difference here, I think, is going to be 20, I think, and then $20 for each additional line. So recall what a recursive formula is. The nth term is the term before it plus your common difference. So therefore, we can write the recursive formula, n minus 1 plus 20. I'm just double checking that that looks okay and that looks okay. All right, let's go to B. So again, right, we know our first is 35. So on the explicit rule, remember, you're taking the first term plus your common difference times n minus 1. So if we want to find the nth term of the sequence, we take the first term, which is 35, and we add on the common difference, which is 20 times n minus 1. And so that is going to be considered, that's the explicit formula for the monthly cost of the plan for n users. Now, remember, the other way we could do this is, another way we could write this is, recall, we have the 0th term plus your common difference times n. So when we can find that 0th term, that's going to be the cost of the first line, and I could go backwards. Even though they don't tell me what the 0th term is, if I subtract the 20, that would be my 0th term. So the nth term would be, you take 15 plus your common difference, which is 20, times n. So technically, we could do either one. We could use this formula right here, or I should say, we could use this formula right here. Either one is just fine and will give you the same term No matter what term you're trying to find in the sequence, you'll get the same answer either way. And recall, another way we can write this, I'm going to turn it around for a minute, 20n plus 15. Remember, if it's asked you ever to write it in y equals mx plus b, you could write y equals 20x plus 15. All right, that is it. Now, if there is still time remaining, you can start working on worksheet number 2, which is in your note packet.